Hey guys, so tonight we're going to talk about one variable equations, and finally it's the easy stuff. But it's not as easy as you might think, okay? So the steps for solving one variable algebraic equations. I know, don't fall asleep on me, but apparently these are some of the steps that you might have learned last year when you were with Miss Yetter or Miss Boozer. Do or undo the distributive property, combine like terms on each side of the equation, combine variable terms to one side of the equation by using additive inverses, combine constants to one side of the equation by using additive inverses, use multiplicative inverses so that the coefficient of the isolated variable is 1, simplify if needed, check your answer for reasonableness, and if a word problem, viability. Say what? What? Okay, let's just make sure that we understand a couple of these things to make sure that we can do this and do this well. The first concern that I would have is this: do or undo distributive property. And we're going to talk about that because technically distributive property also works if there is a quantity in the denominator, okay? Combining like terms on each side of the equation, variable terms using additive inverses, constants, standalone numbers, multiplicative inverses. Several of you had some problems with this when we did the simple things with the big 20s last week. And then check for reasonableness and viability, especially with word problems. If you have a word problem and it says that you have to order 2.2 pizzas and you decide to round down, someone's not going to eat. So make sure you figure out the viability of the answer, okay? So go ahead and stop the tape and see if you can answer these problems, and then I'll work them along. Okay, distributive property, 7x minus 36x plus 66 equals 211. Combine like terms, negative 29x plus 66 equals 211. Additive inverse for the constants, negative 29x equals 5, 4, 145. Divide both sides by negative 29. Divide both sides by negative 29. And x will equal, you tell me. Next one. Do distributive property, 4x minus 8x plus 18. Combine like terms on the same side of the equation. Use additive inverses to remove the constants to the other side. Multiplicative inverse to isolate the variable. You finish the rest. All right, what about this one? Well, this is where we kind of have to talk, okay? It depends on how you want to solve this. There are multiple ways to solve this. One of the things that you could do is multiply both sides of the equations by 6/5. I've got a better idea though. For those of you who are working with fractions, I want you to think for just a minute. Really and truly, what does this mean? Divide by 6. Take this whole quantity and divide by 6. Why don't we go ahead and multiply both sides by 6? This is what I'm talking about with undoing distributive property. These 6's factor to 1, and now you have 5 times 12p plus 4 equals negative 78p plus 4. Now you can distribute the 5 and get 60p plus 20 equals negative 78p plus 4. All right? You can finish this problem. The next one. Oh, Mrs. Rose. Oh, Mrs. Rose. What can we do? Well, in this case, wouldn't it just be easier to take all of the terms and undo the division by multiplying everything by the least common denominator? Well, the denominator for this is 1. The denominator for this is 3. The denominator for this is 7. Why don't we just multiply everything by 21? Don't forget that this quantity should be in parentheses. 21 times this quantity divided by 3 would give us 7 times 2 plus t equals, distribute this 21. 21 times 4 is 84, negative 21 times 6 divided by 7, well, that would be 18. Now, 7 times 2 is 14. 7 times positive t is positive 7t. Sorry, Miss Rose left a t off of here. Equals 84 minus 18t. And you can take it from here. Now, these are called rational expressions, and we're going to spend a lot of time today on how to solve rational equations, okay? In this case, notice that you have a common denominator of 12. We multiply both sides of the equation by 12 to undo the distributive property, and then take care of the math. Please stop the video and write this down. But Mrs. Rose, what happens if there are rationals in the denominator? Well, then it becomes a little bit more tricky. And this is why we had to do multiplying polynomials and what we had to figure out. So if you have a denominator of 2x and you also have a denominator of x plus 1, the least common denominator would be 2x times the sum of x plus 1. And notice what we do. We multiply all of the terms by 2x times the sum of x plus 1. The other thing that we have to make sure that we understand is when you do have a variable in the denominator, remember in the real number system, you cannot have 0 as a denominator. So right away, we need to mention that x cannot equal 0 and x cannot equal -1. Because if it was either one of those answers, then we couldn't do this problem because we can't have 0 in the denominator. Now, for those of you who are hyperventilating right now and you're going, Ms. Rose, you're going too fast. All I want you to do is write down this problem and write down the explanation. We're going to spend all of our class doing this tomorrow. One more time. Let's take a look at this one. 6 divided by x minus 9 divided by the difference of x minus 1 is equal to 1 divided by 4. Notice that the least common denominator is 4x times x minus 1. We multiply this by all of the terms, and then we solve for the problem. Go ahead and stop the video and write this example down. Now, last thing for tonight for homework. These are 10 problems, okay? My bad, not 10 problems. There's 6 problems, and I've given you the answers. Go ahead and solve each of these equations and then make sure that you got the correct answer. If you didn't, these should be your first questions for tomorrow. Welcome to Nerdland. If you have any further questions about solving with variables on both sides of the equation, you can go to Virtual Nerd, and you can go to purplemath.com for the module on solving rationals. But like I said again, do not panic if you cannot do the rationals. That is what we're doing in class tomorrow. Have a great night. See you tomorrow.